Welcome back, class. As you can see, we are today talking about the decimal system. I'm sort of making fun of myself here because I always have a hard time remembering is it EL or AL, and I'm really terrible about it. And I always get it wrong, even when I think I'm psyching myself into getting it right. Anyway, we're going to talk a little bit about how they work, a little bit about how they're put together, a little bit about how to do arithmetic with them, and then, as you probably saw from the title of this video, I'm going to try to show you that the decimal system that most of you already know and the metric system that many of you resist learning are actually the exact same thing. And I don't mean like sort of similar. I don't mean like there are parallels between them. I mean they are the exact same thing. So if you know decimals, you already know the metric system. But that's getting ahead of myself. Let's talk about decimal and what it actually means. Okay, when most people look at decimals, they think about numbers that are not whole numbers. They think about numbers like 2.5 or 9.16 or something like that. And we have this symbol that we call the decimal point, which is essentially just a placeholder, okay? So that placeholder tells us where the whole numbers stop and the partial numbers begin. That 0.5 is 5/10. But again, I'm getting ahead of myself. So let's start with just an ordinary whole number like 1024, okay? 1024. You'll notice that I didn't put a comma in between the 1 and the 0. You can or you cannot. It doesn't matter either way. We should know by now, and I'm not going to review this too much, that this 4 is the ones place, right? It means that there are 4 ones, 4 of whatever unit you're looking at. And if you watched my earlier video on numbers and how they're useful, you know that this 2 represents a group of 10, right? We have the ones go up to 9, and then instead of having a symbol for 10, we just move it over one space and call that the tens, right? And then we call this the hundreds, and we call this the thousands, right? So we have a thousands place and a hundreds place and a tens place and a ones place. When we add the decimal point, we are now going to start talking about factors or scales that are less than 1, right? If I say 1024.987, let's say, what this 9 represents is 9/10. So instead of saying 0.9, you could say 9/10, 9/10, 0.9. Whereas this 8 is in the 100ths place, yeah? And this 7 is in the 1,000ths place. And so on and so forth, right? The nice thing about the decimal system is you can get as large or as small as you have to be with no problem, right? We can have numbers in the trillions, we can have numbers in the teensy-tiny little 0.000001 range. Now, just like any other form of number, the decimal system of expressing numbers has its pros and its cons, and let's talk about those right now. Now, I've been a teacher for a long time and an academic mentor for much longer, and I've noticed that students seem to have a very strong preference for decimals over fractions and mixed numbers. And in some ways, I can see why, but in other ways, I really don't understand. Okay, so the pro to using decimals is, I mean, you already know. Decimals are what you need in order to input your problem into a calculator and get the answer, right? In order to use a calculator, you kind of have to be in decimals. There are calculators out there that will work in fractions and mixed numbers, but they're not like the norm. If you want to do arithmetic using only a calculator, your strong preference is likely going to be with decimals. But it's not always the right way to go, and there's actually a couple of reasons for that. The first is that they can be very inaccurate. If I have a fraction, I think I mentioned this before, like 1/3, well, if I wanted to come up with a decimal for that, I would say it's 0.333, and at some point I have to stop, right? And because this is a repeating decimal, I can just put that symbol on top and show that it goes on forever. But there are a lot of decimals that I can't. What if there's a decimal that goes out 150 digits and then stops? You're not going to write all those 150 digits. At some point, you're going to round. And once you start rounding, you start losing accuracy. Now, accuracy isn't always the be-all and end-all, right? If we're talking about money, then we know that you're going to round to the hundredths place, right? Where the cents are. So, again, different numbers for different situations, but when you're dealing with a math class where you're intended to be very precise, it can often be a big problem if you substitute a decimal early on in your problem, round it off, and then use that rounded off value in later calculations, making your answer more and more inaccurate until by the end of the problem, maybe you have something that the teacher won't even recognize as a correct answer. The second issue with decimals is that they are less intuitive to use than fractions. I can break fractions down into cakes and explain exactly what the numerator and the denominator mean and all of that. It can be a lot easier to tell where in between the two numbers you are if you're using fractions or mixed numbers rather than decimals. Now, with other forms of numbers, I went ahead to show you how to add, subtract, multiply, and divide those numbers using a variety of techniques and considering a variety of different learning styles. But with decimals, I'm going to go with what's already on the board here, and we're just going to say that when you're dealing with decimals, it's probably best to use your calculator. Okay, but what does all of this have to do with the metric system? And the answer to that question is that the metric system is right in front of you right now. This is it, that's the metric system, and I will prove it to you. And I'm going to prove it to you with a simple mnemonic device that my science teacher taught me when I was a freshman in high school. This one's for you, Mr. Stenland. And that mnemonic device is kangaroos hop down my driveway carrying milk. That's it. Take it in, friends. You can see it right above me. Kangaroos hop down my driveway carrying milk. That's the thing that kept this stuck in my head forever. Okay? Now, what does this even mean? Well, what this means is a way of remembering which Latin prefixes go with which denomination. Kilo means 1,000. That's all it means. When I say a kilometer, kilometer, that just means 1,000 meters. When I say a kilogram, that means 1,000 grams. Kilo means 1,000. Okay? H stands for, I believe, hepta, or maybe it's hecta. It's varied, I've seen in different textbooks. This one isn't used very much, but it means 100. Like, you see it with hectares, which is, I think, 100 acres. You see it not very much more than that, now that I'm thinking about it. D stands for deca, D-E-C-A, which you already know means 10 because we have the word decade, or decathlon, right? A decade is 10 years, a decathlon is 10 events in one. M in this case is a it's a ones space, okay? It means the ones place. It's M for meters because that's the basic unit of length in the metric system. But it doesn't have to be meters, right? It could be grams. It could even be feet. You could even go with like American units and use the system here as well. We don't. We never will, but we could. Okay, so this first spot on the other side of the decimal is the Deci Spot, and it means, again, 1/10. If I say a deciliter, that is 1/10 of 1 liter. C stands for centi. That also should make sense because a century, a year, is 1/100th of a century, right? So centi means 1/100th. You also get that same idea with percent, right? Percent is hundredths. And in our next video, which will be about percents, we'll talk about that a little bit more. And M stands for milli. Again, you can think of years. 1 year is 1/1000th of a millennium. So this is literally all there is to the metric system. The metric system is the decimal system, just with different names. That's all. The only thing that you have to know in order to understand the metric system is kangaroos hop down my driveway carrying milk. Now, yes, just like the decimal system, these do go way up and way down, right? You can get nanometers or megameters or that sort of thing. But you don't have to really memorize all of those. In fact, you don't even have to memorize all of these. Like I said, I can't think of the last time I've used hepta. I can't think of the last time I've used deca in an actual metric system context. So if you can stick kilo, deci, centi, and milli in your head, you've got the metric system down for all practical purposes. Now, some people think, wait a second, why the funny Latin prefixes? And the answer is kind of, why not? Like, I suppose I could say that I'm taking 150,000th grams of some medication instead of milligrams. And now that I'm saying that out loud, it's not that bad of an idea. But, I mean, these prefixes have been around for a long time, and the rest of the world uses them, so I'm pretty sure we can manage. Now, I do want to make something clear here at the end of the video. I'm not actually a huge metric system stan. It's not something that I'm going to die on a hill for. You know what I mean? The metric system was more convenient back when I was a student, and even our calculators had to have physical buttons that you would put things into. Right? Yes, the imperial system has a sort of ridiculous and arcane system of converting from one unit to the other, but these days we've got smartphones that can do that sort of thing for you just by asking. How many feet in 5 miles?
5 miles is equivalent to 26,400 feet.
So we don't need to have a nice convenient system because we've got computers to do all of the work for us. But why not understand the system? You already know the mechanics of it. You already understand the decimal system. So why not also be familiar with this metric system? Not because it's somehow superior or better, but because chances are really good that you are going to encounter it in your life, and therefore it will be useful to you to understand it. Even here in America, most tools these days are sold both in imperial and metric units. So if you're going to live in America, it's probably a good idea to have a familiarity with both systems. So that's all I've got for you on the decimal system. Next video, we're going to talk about percents. And we're just going to, again, just like this, sort of skim across the top of what percentages are and what they mean and how they're useful. And maybe I'll do a couple of example problems. Until then, I hope you enjoyed this video. Thanks for sticking around to the end. Please do that like and subscribe and other YouTube stuff. This channel isn't going to be monetized, but the more people get to see it, the more helpful I can be to the community at large. Thanks for watching, and I'll see you next time.